Hi everybody. Come, let's go with braking characteristics of DC shunt motor. In this DC shunt motor having three characteristics. One is rheostatic or dynamic braking of DC motor. Another one is plucking. Then regenerative braking system. This dynamic braking is used to stop the motor by dissipating its stored kinetic energy into a resistive load or external resistance or braking resistance. Once the energy is totally dissipated, the motor stops rotating if no external torque is exerted. In this method, the armature of the running motor is disconnected from the supply and is connected across a variable resistance R. Everything is connected across this black diagram. However, the field windings remain connected to supply. The armature come slowed down. So it rotates in a strong magnetic field and therefore operates as a generator, sending a large current through resistance R. This causes the energy possessed by the rotating armature to be dissipated quickly as heat in the resistance. As a result, the motor is brought to a standstill quickly. The diagram having one motor connected the windings of shunt across this motor. So this black diagram says this is a dynamic braking or regenerative braking. This type of braking is used extensively in connection with the control of elevators and hoist and in other application in which motor must be started, stopped and reversed frequently. For a shunt motor, flux is constant, braking torque that is T proportional to speed. So it has some advantages. Or this method is effective and the motor stop very quickly. This method is adopted for non-reversing drives where regeneration is not possible. So it has some disadvantages. Generated energy is wasted in the form of heat loss at resistance. This method is inefficient in case of failure of electric supply. Come, let's go with next topic of plucking. In this method, connection to the armature are reversed so that a motor tends to rotate in the opposite direction, thus providing the necessary braking effect. When the motor comes to rest, the supply must be cut off, otherwise the motor will start rotating in the opposite direction. Due to the reversal of armature connection, both V and EB start acting in the same direction around the circuit. In order to limit the armature current to a safe value, it is essential to insert a resistor in the circuit while reversing the armature connection. When compared with rheostatic braking, plucking gives better braking torque. This method is commonly used for printing presses, elevators, rolling mills, and machine tools. The speed torque characteristics under plucking condition is mentioned here. This graph represented by voltage and armature current. Those comparison having negative feedback of speed. So external resistance could could be connected across that diagram. So speed always having that voltage and armature current dependence. So we can get a torque TD equal to constant flux armature current. So the plugging having some advantages. In this method, quick stopping is achieved. For reversing the drive requires a short time for reversal. Then third classification is regenerative braking. In this regenerative braking, the motor is run as a generator. As a result, the kinetic energy of the motor is converted into electrical energy and returned to the supply. Regeneration takes place when back EMF becomes greater than voltage. This happens when the overhealing load acts as a prime mover and so drive the machine as a generator. Hence, the direction of armature current and armature torque is reversed and speed falls until back EMF becomes less than applied voltage. During slowing down of the motor, power is returned to the line which may be used for supplying another train and an upgrade motion, thereby relieving the power supply house a part of its load. This method is used when the load on the motor has overhauling characteristics. The lowering of the case of hoist or downgrade motion of electric train. From the characteristics curves, it's clear that higher the armature circuit resistance, the higher is the speed at which the motor has to run for given braking torque. This is the kinetic energy converted to electrical energy which can be usefully utilized or returned to supply means this is one kind of advantages of this. Then energy efficiency also increases. It has some disadvantages. Need a set of battery bank to store the regenerative energy. Next, low force capable to accelerate the motor which is greater than the no load rated speed. Thank you.